Hello and welcome back. So in this video, we are going to discuss more on the activation functions. So much more details regarding the activation functions. Let's see what are the activation functions. We have done a small understanding. We have taken a small understanding in the previous video. So activation functions are just the deciders in the neural network. They are the real processing components in the neural network. So you can imagine the neural network as a team of workers. Okay. And each of the worker is responsible for performing a specific task. So these workers receives information, process it, and then decides whether to pass it to the next worker or not. Right. So activation functions are like the decision makers in this team. So you can imagine, again, we can take the same example, like the example of a cat. So if you are training a model, right, to identify cat, and you have given the face has the more weight, is the highest weight to identify a cat, right? To learn that this is a cat, you are giving the weight to the face, the highest weight to the face. Then comes the stomach and the fur around the body, and then the legs. So if at the first layer of the workers, or you can say the neurons, so these workers, if they identify that yes, this is the face of a cat, then in that case only you need to move ahead. Otherwise, there is no need to move ahead, right? So that's how it decides. The activation function decides whether the next layer of neuron should fire to identify the next part of the body. I'm just giving an example. There are many complex use cases. So what do they do? What exactly activation function does? So it introduces the non-linearity. Whatever you are able to see on my screen, this you will not be able to find anywhere on the internet, because these are my personal notes created from various sources after taking some understanding, and then I'm presenting it to you. Okay, but yeah, let me tell you that with the help of these examples, you will be able to get a fair understanding around the neural networks. So just like real world problems are not always straightforward, right? Neural networks need to handle complex patterns, right? Because if you are considering a cat, then the cat, to identify it, could have the face in front of you. It may have the face, the side face, and you have to identify. You are still able to identify that yes, it is a cat. If you are able to see the back side of the cat, then also you are able to identify that yes, this is the cat. But can you imagine if you are training a machine learning model to understand in the same manner, then how complex it could be for it, right? So until it understands from the complex inputs, it will not be a robust model. Right? That's why the activation functions help to introduce the complex patterns, so that learning the complex things, your model will become more robust, right? This is similar to using the same example in the previous video, just like I use. If you practice these small, simple questions in the mathematics, then you are not going to be a good student of the mathematics. Similarly here, if you are not training your model with the help of the complex patterns, then obviously your model will not be robust, and at one point or the other it will fail to identify the cat or any image for that matter, right? Decide whether to fire. The second thing it does is to make the decision whether to fire or not. So you can think of an activation function as a gatekeeper, right? It decides whether a neuron should fire, produce an output, right? Whether your neurons should produce an output or not. If your neuron is not going to produce any output, then you are not going to reach to the next layer of the neurons, right? So based on the input it has received, it decides whether I have to fire it or not. If the input meets a certain threshold that I discussed in the previous video as well, so if the input meets a certain threshold, then the neuron fires and passes the information on to the next layer, right? So now let's see the different type of activation functions. So the very first one that you are able to see is a sigmoid function, right? So the sigmoid function squashes the value between 0 and 1, right? You know that between 0 and 1, it's a continuous, function, right? Sigmoid function is a continuous function, and it plots the graph between the value of 0 and 1. So if you are talking about the 0 and 1, then obviously the values will be the binary values. For example, you have to decide whether a person will buy the policy or not. insurance policy or not. So either they will buy the insurance policy or they will not buy the insurance policy. So in these scenarios, there is nothing like in between, right? Either they will buy or not buy. So it's a binary kind of situation. So for these kind of situations, these kind of scenarios where we have to train our model to identify whether some person will buy insurance or not, you have to train it on certain data. You have to bring some data where you have the data related to the people who bought the insurance based on their age, their salary, and all that, right? So this sigmoid function is used that in that case, right? So you can imagine it as a light switch as well. Another analogy you can understand with the help of the light switch. So sigmoid function is like a light switch. It's either on or off. There is nothing in between. But you can see that this, either 1 or 0, whatever you are understanding, this is a continuous value, right? In case of 0 and 1, right? So between 0 and 1, you can see the top one is 1 and the lower one is 0, right? So between 0 and 1, all these values had been spread out, right? Okay, so the next one is rectified linear unit. This function outputs the input directly if it is positive, otherwise it outputs 0. Okay, so it's like a one-way street. It allows positive signals to pass through but blocks negative ones. So if there is something like this kind of situation where you have to allow certain kind of things to be the deciding factor, but yeah, you don't need to allow the other things as a deciding factor, then in that case, you will be using this one. I mean, you have 0, right? You have 1 in case of sigmoid, but in case of this one, you have, -1 to 1 in case of ReLU, rectified linear unit. Okay. Similarly, it is related to the tanh hyperbolic functions. So in case of hyperbolic function, it again, squashes the input to a value between -1 and 1. It's similar to the sigmoid function, but has a wider range of output values. So you can see here, like it's from -1 to 1. It is going from -1 to 1. You can see the -1 and the +1. So this is the tanh curve. So you can see this equation, right? This is the equation. You don't need to understand this equation. This you must have understood in your college days. So this is the function of tanh e raised to the power z minus e raised to the power minus z upon e raised to the power z plus e raised to the power minus z. So when the values need to be spread more, right? You might have the situation where you need to use the tanh. So we are going to see the different scenarios when you use the tanh and when you use the ReLU functions. So all those we will discuss in the coming videos. But yeah, here we are going to give you a brief overview only, right? So these are the three functions. This only shows that how the values that we are going to train to our model, how they will be spread out, right? So tanh, sigmoid, and the rectifier linear unit, ReLU, these are the three different activation functions. Now let us understand why they are important. I hope you must have understood earlier as well that why they are important, because without activation functions, a neural network would be limited to solving only simpler linear problems, right? They introduce the non-linearity, right? Because the things are complex, right? So we must need to introduce the non-linearity, and based on that non-linearity, we have to train our model so that it can learn the complex patterns and make accurate predictions. That is why we are using these kind of functions, right? So you can see the different equations of the function. So that we are going to see in the next section. So in essence, activation functions are the decision makers in neural network, introducing non-linearity and enabling the network to learn complex patterns. So this is the essential definition of the, this is the essence of the activation function. I mean, this is the essentiality of the activation function, why they are needed. They are the decision makers in the neural network. Now let us see in the next video about the sigmoid and the ReLU function and the tanh function in detail, like in what scenarios they need to be used. Okay, so with this, I would like to conclude this particular video. We'll meet in the next video. Till then, have a nice day and bye bye.